Wait for that to come up. Meanwhile, get the screen share. Wait for that to come up. Meanwhile, okay. Let me hide this and hide that. All right. Let's take a look where we are. All right. So we are in week number 12. And we are the last stretch, huh? Let's see. So yeah, we had discussed Mongo earlier this week, and we installed a local server and started it, and we were able to log into it and interact with it using the Mongo client. We were able to store data, retrieve data, update data. And so today what we're going to talk about is how to do that, but programmatically. You know, very much like we did for Java, where we were able to connect remotely with a database, right, so that we can control it remotely programmatically. We want to do the same thing, but using JavaScript from Node.js, be able to control a non-relational database as opposed to using MySQL, a relational database that we use for interacting with Java. Instead, we're going to try and communicate with a non-relational database, MongoDB, from Node.js. So we already demonstrated how to do this manually. So today we'll be learning about a new library called Mongoose that allows us to connect to the non-relational database and program it from afar. There won't be any lecture on Monday since it'll be a care day. I'm not quite sure if that replaces the Monday, April 19, which was supposed to be Patriots Day. Not sure if that's there was no supposed to be any lecture then, so I'm not sure if it's just, they just swapped those 2 Mondays. Hopefully we get that that day, at least the 19th, so that we can continue some more material. You are currently working in an assignment, A8, which is due the 19th. Also, the starting I guess today, but definitely next week we're going to be discussing more of the project. So if you have any questions, any challenges, anything that you want to cover that would be good to cover for the whole class, please come prepared with questions, or maybe you can suggest them on Piazza, and then I can gather them and we can cover them next time we meet. You know, we could maybe do some more about authentication, cookie handling, tracking, things like that. So come up with ideas, and we can discuss them next Wednesday. There's also going to be a quiz later next week. I'm not sure if I'm going to move it maybe from 12th to the 14th. Since the 12th is a care day, although I usually give you a few days for you to take it, so you can take it any day after that. When we come back from Patriots Day, or that last Wednesday that we meet, that's our last class, and that's we're going to review the for the exam that is going to have the same, more or less the same pattern, right? That we'll give you sample questions, which we're going to solve here in class, and then there'll be an exam starting Monday the 26th, which usually I'll give you the same thing, right? You know, 3-4 days for you to take that exam. Same format, multiple choice, fill in the blanks, you know, same kind of deal. I guess I don't have the when the project is due, but I believe it's in the in Canvas. So anyway, so that's a plan for the next couple of weeks. Let me know if you have any questions, any concerns. Reach out to me, and we can chat. All right. Okay. So let's keep working where we left off last time. Let's see. We had started the Mongo database, so let's do that and get us to where we were. So let me bring it up a terminal, and let me go to where we do all our work, web dev, and 2021. Let's go to Spring, and then 02, and there's web dev server node. And it looks like we did create a data directory where we're going to have MongoDB store all its data. So let's start MongoDB and tell it to use that directory. So that starts up Mongo. In a separate tab, let's start up a client. So just Mongo. Let's see what we've got here. So show DBs. Okay, so it looks like we had started playing around with a whiteboard database. Let's see what we put in there. We'll say use whiteboard.2, and then we'll show any collections that we might have put in there. It looks like we added some sections, some users. So let's see any users that we put in there. Okay, so yeah, we were playing around with some users, also I believe some sections as well. There we go. So what we're going to do today is learn how to interact with the database, but not here from the console, but instead from Node.js, using JavaScript and the library Mongoose. Okay. All right. So I did open up the project that we were using last time around, which is this Node server, right? That we had created we had created this service, the simple service with some demos, some quizzes, controllers, right? That were able to respond to a query, right? For retrieving all quizzes or a particular quiz by its ID, and all implemented through these services, right? That the only thing that they did was just retrieve data from this static file, this JSON file. So what we want to be able to do is replace this so that we can instead retrieve data from the database, not from this hard-coded file. Excuse me, it's kind of hot in here. Sorry. Okay. Yeah, so we want to be able to communicate with the database and retrieve quizzes not from this hard-coded JSON file, but instead from the remote database. So first of all, let's populate our database based on data that we gave you from the assignment. Is everybody still logged in? Yes, right. So let's look at the assignment. I believe that there's some sample data that we ask you to use. This one, NoSQL. And let's see what we've got here. We do give you a couple of documents to use for a sample for quizzes and questions. We'll give you a couple of documents, right? This is the same data that we gave you earlier in the previous assignment that we stored in the JSON file, but now instead we want to put them in the database. So let's do that. We're going to create a couple of quizzes. So I'm just going to grab this quiz and I'm just going to insert it in here. All right, notice that we don't currently have any quizzes or questions, right? These are the only two. These are the only two collections that we have, right? So to insert quizzes, we can say db.quizzes.insert, and then we can paste in that quiz, right? And looks like that was successful. Let's add another one, 2, and this will be maybe, and then another one. Notice that I'm using the ID here. I'm explicitly saying what ID I want. And so it's not generating the ID for me, right? If I ask it for the quizzes, notice that indeed it's using my ID. If I had not used the ID, say I add a fourth one, if I didn't include the ID, notice that instead it would have generated the ID for me. Okay, so there's no such thing as like an auto increment. If you leave out the underscore ID field, it generates the ID for us. Okay. The only reason I'm asking you to use these explicit IDs is that it simplifies the grading for the TAs, right? If you're using these IDs, they can run certain scripts to test based on knowing that these are the IDs that you use. Instead, you know, if you're using your IDs, then it complicates the grading. Okay. Anyway, so we added a couple of quizzes. And we can do the same thing for questions, but let's leave that till later. So for now, what we're going to do is that we want to be able to connect to this. We know the database, you know, so we say show DBs, right? So this is the database that we want to connect to. Also, we know the collection, right? The quizzes collection is the one that we want to connect to. So to do this, we're going to use a library called Mongoose. Mongoose.js, and so it's definitely a great library to learn. We only need these just these 2 lines, and we're connected to the database. But first we need to install the this tool. So we're going to install it. We can install it right from within our IDE, right in the terminal. We can install it, or from the command line too, right? If we are in the correct, yeah, we're in the correct directory. We can say npm install mongoose --save. Okay, so the library is called Mongoose. So we do that. It's going to copy down Mongoose from npm repository, and once we have it installed, we can now use this code to connect, right from the server, right? The first couple of lines, we can add our connection to the database. So we can paste that, and so that's going to load the Mongoose library dynamically, and it's going to connect to this database. Okay. Notice that MongoDB, this is the protocol that this connect function is going to use to connect to MongoDB, as opposed to MySQL or Oracle or whatever, right? This is vendor specific, right? In our case, it's MongoDB is the vendor, the provider of the service. Then you have the name of the machine or the IP address where you are connecting, and any port number where the database server might be listening to. And then last one is what the name of the database. And the name of the database we saw was Whiteboard.2. Right? So let's paste that in there. So that's going to connect us to the database, right? And we're done, right? Once we are connected, we need to be able to interact with the database. It's going to log in, it's going to connect, and we need to be able to do queries such as this one, right? db.quizzes.find. We need to be able to do that, right? So somehow we need to tell it what collection we want to communicate with, right? And then issue a command to retrieve the data from that particular collection. And the way we do that is that using the Mongo library, right? We need to define the structure of this data in the application. We need to say, hey, the data that I want to retrieve from the server has this structure, has these fields. Those fields are for a particular data type, and so forth, right? So let's do that. And we also need to tell it from what collection do we want to retrieve it from, right? So to do that, right, we're going to head over here, and according to the assignment, I believe I asked you to do that where? I believe I asked you to do it in models. Let's do that, right? In a dedicated directory called models, right? We're going to create models for each one of the collections that we want to talk to. We want to talk to the quizzes collection, and later on we want to talk to the questions collection, right? So let's do that. Let's create directories for each one. You don't have to create directories, but because we need 2 files at least for each one, that's why I'm creating a directory, so that I have it nice and tidy. So I'm going to have here for quizzes and a directory for questions in here. Okay. So in quizzes, we're going to have 2 files. The first file is going to declare the structure of the data that I want to interact with. Okay, so this will be it'll be quizzes and schema. So schema is a fancy word for saying structure, the structure of the data. Okay, and the way you structure data in using Mongoose with the library is as follows. You first load the library, and once it's loaded, you can create a schema, a structure. In our case, is the structure for the quizzes. We use a function called schema, which is part of the Mongoose API. Okay, and schemas allows you to declare the structure. Very much like you see here, there are key value pairs, right? Key value, key value. We need to be able to specify that structure, key value. So the keys here is the name of the field, and then the value is the data type of that field, right? So I guess most of them are strings, not all of them. I guess here we have one that is not a string. So I'm just going to remove that one so it doesn't give you any error. So we're going to say db.quizzes.remove, and I'm going to remove the quiz whose title is 4, so that we're back to just these 3 quizzes, right? And those IDs are all strings. Okay. Then we have a title, right? That's the other field there. So we can say title. Title is also a string. Okay. All right, that's it. Plus any other fields we might want in there. And you can also specify the collection that you're going to be connecting. Where are we storing all this data? We're storing it in a collection called quizzes, right? That's the name of the collection right here, right? Okay. All right, we're done here. We're going to export this. So module.exports equal quizzes schema. Right, so this only declares the structure of the data of whatever it is that we're connecting to. Notice that it plays the part of a little bit of what we missed on the Mongoose. Right? So MongoDB, notice that it doesn't care really about the schema, right? Nowhere in MongoDB did we specify that quizzes have a specific structure. Right, so we had said that the responsibility for that is now moved over to the application level, and here it is. This is the application level, and this is how we are handling the schema. We're not burdening the database for doing this, right? Instead, we have the application do any validation that the fields are called _ID and they're called title, and that they are the specific data type. We're doing all this validation at the application level right here, not at the database level. Okay, as opposed to the way we did in MySQL, we declared the schema, the table saying that these were the fields and these are the data types, and everything was validated against the schema. We're not having the database do that now in MongoDB. Instead, that responsibility is moving on to the application level. Okay, now that we have the schema, we need a means for executing these commands like .find, .update, .remove, right? And that is done through Mongoose's models, right? Mongoose declares what are called models that allows us to interact with the database, right? It provides us with several generic functions, you know, like .find, .update, .remove, all those, right? So that we can interact with the database. So let's do that. Let's create here a model. So this will be a quizzes model. And the model, the only thing that it does is that you you declare, you know, what it is that you're interacting with, right? In this case is the schema, the quizzes, right? So let's load that. We need to load the, well, first of all, we always need to load Mongoose, right? So let's do that. That is the main library. Then we load the user schema. And this is the schema, there it is. Not user schema, the quizzes schema. So quizzes schema. So once we have the quizzes schema, now we can declare the model. We can say that the quizzes model is Mongoose model. Okay, and here is where you declare, it takes two arguments, right? The first argument is it's an arbitrary string that needs to be unique. Within the application, it needs to be unique, and it's how the model registers itself with the Mongoose infrastructure and says, "Hey, I'm a model," and so it can be found. We can retrieve this model by name, whatever name you give it here. So a common name that we use for models is we start off with the, you know, what it is that we are modeling. We're modeling quizzes, right? And then the keyword model. The second argument is the schema. In this case, is the quiz schema, right? And basically, this is saying we want to be able to, you know, give me. We're asking Mongoose, give me an object, in this case, quizzes model, that's going to allow me to read and write these quiz schema. Right? It's going to allow me to insert, right? And it's going to allow me to find and retrieve or update or remove these guys from where? From the collection that the schema is mapped to, right? So that's how, you know, the model knows where to write, right? Where to save the data to the collection where the schema is mapped to. Okay. It also knows that it can, you know, if it's going to create or if it's going to insert new quizzes, well, it knows that it needs to follow this structure declared on the schema. But it is the model who provides me with the function of inserting into the database, right? But it needs to know what it is that it's inserting, and there it is. Okay. All right, so we have a model. Let's import this so that we can export it so we can use it elsewhere. Quizzes model, there we go. So yeah, there we go. So now we have everything we need to start interacting with the database, right? So where is the interaction starts? Remember, the interaction starts at the controller, right? The controller, right, it's listening for these incoming quizzes. Let me run the node here. I'm gonna create an executable here called server, and it's going to point to our server.js file, and I can run it. So it's running, so I should be able to retrieve. Wait, somebody's. We can retrieve data, right? Localhost 3000 API. We can say quizzes. Now, these quizzes. Oops. Why is this not running? Okay, quizzes. Let's see. Server. Oh, so this thing at port 4000. 4000. Okay, sorry. So 4000. There we go. So yeah, so this is the this API that we have so far looks very much like what's in the database, right? And so how are we going to distinguish this? Well, actually, we can change it real quick locally here. Locally here, the services is using these JSON files, right? So let's change these a little bit so that we then know that we're getting things either from the database or from the JSON file. There we go. So this is, there we go. Let's save that. And let's restart the server. So if we refresh, okay, definitely these are coming from the server, not the database, right? Because in the database we have these. Okay. All right. Yeah. So we want to be able to replace the fact that this controller, right, when we ask for all the quizzes, is coming here, then it's going to the service, and then the service is just returning this array. Right? It's just this array, which is hard-coded array right there. Okay, which is exactly what we're getting here. So we want to replace that so that instead of the service getting the data from a hard-coded JSON file, we wanted to get it from the database. Okay, and the way we do that is through the model, right? So let's do that. Let's grab the model. Quizzes model. We're going to require. We're going to go up one and then up again, down to the models, and then the quizzes, and then the quizzes model. Okay. Once we have the quizzes model, we can start replacing this, right? So that instead of returning a hard-coded JSON object, we can use the model. Remember, the model is going to give us the capability of executing these functions, this .find, .remove, right, .update, okay, right? So that's through the model. So if I say dot, you'll notice that we have several functions that definitely look like they're useful, right? .remove, .find by ID, yeah. Right, so these are all generic functions that allow us to, talk to the database, right? And in particular, we have find. Find is it's kind of like the workhorse, right? It has everything we need to be able to talk to the database, retrieve data from the database, right? So what we're going to do is that we're going to return whatever find returns, right? Now, unfortunately, .find. I mean, when we run it from the command line, .find seems to return what we want, right? Unfortunately, this doesn't return exactly what we want, right? Instead, what happens is that .find, it's an asynchronous function, right? And what we mean by asynchronous is that this .find function it's a non-blocking function, right? Meaning it's going to go and send a request to the server, right, through the network, but it's not going to wait, right, until the response to come back. Instead, right, it's going to send the request, and boom, it's going to continue doing whatever it wants, right? At some point, the response is going to come back from the server, and we need to be able to catch it, right? We need to be able to register for a callback, right, so that when that comes back, we'll be notified. And so that's exactly what we're going to do, right? So this return right here is not returning actual data. Instead, what it's returning is, you guessed it, a promise, right? .find returns a promise that is going to allow us to register ourselves for that callback, right? So that means that the controller who's using this, right, it's expecting an array, but they're not going to get an array, right? So we need to rewrite our find little quizzes because here we're expecting an array, right? But that's not what we're going to get. So what we're going to do is we're going to comment that out. Okay, we're still going to use the same function, but instead we're going to register for a callback using the promise API that we've been using all semester. And here is where we're going to get the actual data, quizzes. Okay. And once we have the quizzes, then we can send the data back, right? Notice that right here, okay, I'm going to cut it from out here and I'm going to put it inside of the then. That's very, very important. Okay, I cannot leave it here because out here quizzes don't exist. Right? They only exist inside of this .then. Okay, right? Also because if it's out here, okay, this right here is again, it's an asynchronous call, and once it makes that call, it's not going to block. It's going to continue on to the next line, and by the time it gets to this line, the quizzes don't exist yet. Right? They haven't come back from the server. So we have to move it inside of the then, right? So that by that time, right, we are notified with the actual data, and then we can respond with it. Okay, very important. Also notice that find all quizzes here, right? Notice that it returns the promise, and then immediately we can receive a response including the data. This is entirely different how we do this on the client on React.js when we do a fetch. Remember, there's two .thens involved. The first .then deals with waiting for the response to come back from the server. The second .then deals with the fact that the response that comes back from the server is embedded inside of a body, right, of an HTTP body, and that body, right, is being streamed. Right, the bits and pieces are still being streamed over the network. That they need to be built up and sequenced, right? And then we're going to have the data out of that. So there's two .thens that work in tandem there. Not here. Here there's only one .then, right? There's no response body, anything like that in the response that comes from the server. The server just responds with the data itself. Okay. All right, there it is. So we have substituted the use of the array, of the hard-coded array, returned by find all quizzes, which now is sending back a promise. Let's try it out. Let's run this, and let's go back to the client. Notice that this used to be 111, 222, 333. Now, if we run it, notice that now we get the correct data coming from the database, right? And if you don't believe me, we can insert a new quiz. Let's see. Let's insert another quiz, quiz 4, whose ID is 456, comma, and then the title is quiz 4. So let's look at, we've got 4 quizzes. If we come back here, we refresh. Notice that we have those 4 quizzes. Okay. All right, excellent. So we were able to replace the find all quizzes in the service. Let's now replace the find quizzes by ID, right? That one too is also implemented using an array, right? So we're going to comment that out, and instead we're going to use the find quizzes model. So we could do it a couple ways. So one of the ways is that we can just use find. We use find, and then filter, right? We can filter. We can say we can filter the ID and match it with quiz ID. Quiz ID. Actually, before we do that, let's see what it used to do. What it used to do. So 111, there it is, right? It returns the object for that ID, and this is still using the data in the array, filtering out the object in the array. Yes. So with this new implementation, right, it's going to filter by the quiz ID that we pass it, right? But instead of iterating over the array, right, it's going to retrieve from the database. Okay. Now, again, this is going to return a promise. It doesn't return the object itself directly. It returns a promise. That means that we need to rewrite the controller. Right? So the controller here, this is the same thing, right? We retrieve the ID from the path. This time around here, right, instead of returning the actual quiz, this is going to return a promise. And finally, the quiz is going to be out here, which we can then respond and send it back. Again, we have to move this inside of .then, otherwise this won't work. All right, so let's restart the server and see if this works. All right, so let's refresh. Okay, that doesn't exist anymore. Let me look at all the quizzes. There we go. So let's retrieve a particular quiz, 234. There it is. It works, right? But it looks like, notice that it's returning still an array, right? Even though it's just one element. And our other implementation didn't return an array of one element, it returned just the element. Okay, and that's because find always returns an array, even if it's just one element. I mean, what we could do is just unwrap that element because we know it's just one, and then just return that. I mean, we could do that, right? We could do maybe sub-0. We could do that. Right? We know it's just one. Or better yet, what we could do is use another version of this. Let's copy that and leave it alone. We could instead use what it's called find by ID. See that? Find by ID can take just the value of the ID. Instead of a filter JSON object, right? It can just take as argument the ID itself and knows that it's filtering, comparing against the underscore ID, obviously, right? So let's run that, and if we do that again, notice that now we do get just the object, right? So find by ID knows it's unique, right? And it's useless to return an array, right? It returns just that object. Okay. All right, excellent. Let's keep going. Right, so we implemented those two. Now, just to practice, right, and make sure we understood this, right? Let's do it again for questions, right? So we get a chance to practice this again, right? So let's, again, real quick, what do we need? We need the schema. So we need the question schema, questions schema, okay? And the schema is based off of the data that we are inserting. Let's see, so maybe we should insert a couple of questions. Let me insert this one. So this would be db.questions dot insert. And I'm just going to paste this, copy, paste. Yeah, there it is. Let's insert yet another one. Paste. Okay, there we go. Let's insert another one. Okay, and then maybe yet another one. Okay. And we can retrieve all of them by saying db.questions.find.pretty. There we go. We got 1, 2, 3, 4 questions. Perfect. Okay. All right. So let's and you can do the other ones. So let's create a schema. So it looks like questions have a title, a quiz ID, the question itself, whether it's correct or not, the type, the choices. So let's do that, right? And the ID. So let's create the schema for that. So to create the schema, we need Mongoose first. Right, we need, now we can create the questions schema using mongoose.schema. And here is the structure, right? They all have an underscore ID. Oops. So we have an underscore, what the, what's going on? Okay, underscore ID, it's a string. We have a title. So title is also string. We have a quiz ID, which looks like it's a string. Right, so that's going to allow us to relate questions to their quizzes. The actual question is also a string. We have the correct answer, which is a string. The type, which is a string. Now, this is not just any string. We would like to be able to specify the valid values for that string, right? So that you don't make a mistake and enter the wrong type. So the way you do that is that you, instead of this being just the data type string, you put this inside of a JSON object, and you say that the type is a string. It's just a coincidence that this is a type and this is a type. Okay, this is a type in our data model. This is a type as part of the Mongoose model, right? Yeah, so it's a string, but it's not any string. It needs to be from the following enumerated values, right? It can only be either true, false, right, or a multiple choice, right? There you go. It can only be those. Plus, what do we have? We have choices. Choices is also another field. Now, the data type here of choices looks like it's an array of strings. So the way you specify that is that you use the square bracket saying that this is an array, and the data type is a string. Okay. Let's see. Is the question in the chat? Does MongoDB have any keyword cannot be used by us? Yes. I don't remember what they are, but yes, there are a few keywords that you cannot use. I don't remember what they are. I did run into issues of using a keyword, and it just gave me a big headache why it wasn't working. So another thing here is that what we need to do is map it and tell it where do we want to store this, right? And we want to store it in the questions collection, right? So we're going to say that the collection is questions, and then we can export this. So module.export .question schema. Perfect. Okay. Okay. Now that we have that, right, we need an object, a model that is going to allow us to actually interact with this. So let's head over to the parent directory and let's create a model now. So this would be not a directory, but a file. So cancel. So this will be new JavaScript again. So this is questions model.
What happens if you don't provide a collection, or if you provide a collection that doesn't exist? A collection?
Yeah. So what if you don't provide a collection, it will pick a name for you, and it will base the name on what you call the model. So for instance, if I didn't pick out the actually, let's try it out. Right. Let's in the question schema, let's not put the collection. What it'll do is that it'll use the name of the model as a base for the name, right? And it'll put like we'll try to make it plural, right? We'll see. So we have this question schema. Let's create the model. So here's the question model. We'll need Mongoose, require Mongoose, and we'll need the schema, right? We'll need the question schema, require question schema. There it is. And now we can create the questions model. It'll be mongoose.model. And we'll need two things here. We'll need the name of the model, which will be questions model. So the name of the collection will be based on this name, and then the actual schema. So it's question schema. There it is. And that's it. We're going to export this. So module dot exports the questions model. Okay. This is very much like we did in Java, right? That if you just annotate a class with entity, it assumes that the name of the table will be the same name as the class. And that when we overwrote that by using the annotation table, and then we overwrote it and said the explicit name of the table that we wanted to use. So same thing here.
So
it's going to assume the name based on that. Go ahead.
If you provide a collection that is not set up in the database, will it create a collection?
Yes, it will create the collection that you specify there. Yes, if it's already there, it'll use if it's there. If not, it'll create the collection. Or if you don't provide the collection, it'll use the name of the model. Yep.
Thank you.
Yeah. So right. So we got this. Now let's head over to the service and let's see if we can rewrite the service. Service for the question. Right. So the service has the following implementations. Right. We have the data instead of questions JSON, and we want to replace that. And let's replace this one. So find all questions. First of all, we'll need the model. Let's just retrieve the model. So const questions model require, we'll go up and then down the models, then questions, and then the model. There we go. So once we have the model, we can replace this and say that we're going to return questions model dot find. So that should return all the questions, but obviously that returns actually a promise. So back in the controller, we need to rewrite that. So in the questions controller, where we retrieve all the questions, right? We cannot use this because that's a synchronous call. So instead, right, this is going to return a promise that is going to return the actual questions, and then we can send the questions back. Okay. All right, let's try it out. Let's actually, it's not going to return any questions because we put them in the different collection, didn't we? Right? We put them in the different collection. So if we ask here for the questions, is it running? Wait, is this running? Oh, it's not running. Oops, is it giving me an error? Oh, it is. Looks like we can't find question schema from question model. Did I misspell it? Oh, it's dot slash. Let's try it again. Okay, let's refresh. Okay, it's returning empty because it's looking for a collection that doesn't exist. So show collections. Yeah, we stored it in questions, and it's looking for it's looking for question models, right? Which is not finding it. Okay. So if we go back to the schema and actually give it a collection, and we say that it is questions, then this should work. Questions. Oh, collection. Let's see. There we go. Right there are the questions. Okay. Yeah. So we retrieve that. Similarly, we can implement the find question for quiz. right? That's based on this quiz ID. We want to retrieve by this quiz ID. So for that, right, we have the model. Here's the model. And we're going to return the questions model dot find. And here the query will be something like, if we go here, right, if we have we show all the questions we get. We have one question for quiz ID 345, and then we have another question for quiz ID 234, another one for 234, and another one. So we have 3 for 234, and we have 1 for 345. And the query would be something like, DB dot questions, yada, 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 find, and then here would be quiz ID, colon, and then whatever you want to query. So 345 returns just that one. Or if you say 234, it returns 3 of them. Okay, so similarly, we want to use that same query right here, like that. So ours would be same thing, would be based on quiz ID. Right, the field is quiz ID, and the value, we're passing it to you as an argument, like there. Okay, and what we return from here, we return a promise, right, not the actual data. So the controller would need to be rewritten, right, so that so this one, right, instead of retrieving the data right away, right, it will look like this, right? So let me rewrite this. So it's dot find questions for quiz dot, and then there's a then, right? And then these are the questions coming from the database, which we are going to send back. There we go. Let's try it out. We start the server. And so these are the questions. And so we can, so 1, 2, 3, 4. So there's 4 questions. We can retrieve question, no, what was it? Quizzes / 345 questions. There we go. So we got the questions for quiz 345 or the questions for quiz 234. 234 returns those 3. Okay. All right. Does that make sense? Any questions? All right. I'm going to leave it. Yes, go ahead.
The how to model the data. I've seen it like with references or embedded. How do you decide which way to go?
Oh yeah, let's talk about references and data references. So for instance, one of the things that we'd like to be able to do, right, if we go to quizzes, so these are all the quizzes, right? Now, the way we are modeling the questions is that the questions have references to their parent, right? As opposed to the parent having references to their children. So let me show you how to do it the other way. Instead of having the children pointing to their parent, you can have it the other way around where the parent points to their children, right? So for instance, in the quizzes schema, you can say that, right? So as opposed to in the question schema, we have a reference, the children have a reference to the parent, or you could have the parent having an array of quizzes, okay? An array of quizzes of what? Well, it would be, this is going to be a JSON object, right? Because we're going to say, well, you are going to be pointing to what? To these IDs, right? Just like the questions have an ID, and they are of type string, right? So we're going to say that the type is string. So you're going to be holding references, and the references are, you're going to be holding all the IDs of your questions, okay? And not only that, right? Well, actually, no. Let me show you this first. Let me show you this first. So just a string, Okay. Okay. So if we restart this, and now you ask for the if you ask for the quizzes, refresh. Notice that now they all have a quizzes with an array. See that? Which is empty right now. Okay. And with questions, we have a whole bunch of questions, right? So these 3 questions, 2, 3, 4, right, belong to the quiz ID 2, 3, 4. So let's add them. Let's add these questions 1, 2, 3, 2, 3, 4, right? And well, I guess just those 2. Wait a minute. 1, 2, 3. Yeah, 3. These 3, right? These 3 belong to 2, 3, 4. So the way you would represent them is as follows, right? If you look at the quiz, if you say db.quizzes.find, right? So presumably this has 3 questions. So let's do that. Let's update this. So db.quizzes.update. We're going to update the quiz whose ID is 2, 3, 4. I'm going to set, right, a new field called quizzes to be an array of strings, of 3 strings, right? Of quizzes 1, 2, 3, quiz 2, 3, 4, and quiz 3, 4, 5, right? This is something you can't do with relational databases, right? Usually the only way to do a one-to-many relationship in a relational database is to have the children point to the parent, and that's it. That's all you can do. But here you can go the other way around because my fields can be arrays, right? And so I could have a parent having references to a whole bunch of children. So if I go back here and I refresh, you'll notice that if I go back to the quizzes 2, 3, 4, notice that now it has the references to the children, okay, which is basically an array of strings. And that's how it's being modeled here as an array of strings. But I could go a little further and say, well, I want you to treat them more than just strings, right? They are references. What are they referencing? They are referencing these questions models, right? They which have this structure, right, of titles and quizzes and questions and correct and types and choices, right? So if I go a little further here, right, and not only say that it's a string, but I go further and say, okay, well, yes, the type is a string, so definitely you are just storing string. That's all you're storing, but don't treat them just as strings. Treat them as references to this questions model, right? They are references to questions model, right? So by going that further, right, if I restart the server, this, the default behavior is that you still just are only ever really storing strings. That's only what, as far as Mongo is concerned, you are only just ever storing strings, right? Mongo doesn't even know that these strings are actually referring to some other document in some other collection, right? And Mongo will never know, okay? But from Mongoose point of view, from the application's point of view, right, by adding this feature, right, we can have something that looks like a join, right? If you remember, in relational databases, joins allows us to take the value of a field and say, oh, the value of this field actually refers to the value of this other field. They are related to each other, okay? And then by joining, you can aggregate data from multiple sources, right, from multiple tables, right? And then combine it into one big thing, right? Mongo doesn't have that. Mongo database does not have that. But here at the application level, we can have something that looks like that by telling it, hey, these two schemas, even though they live in two different collections, they are actually related to one another, right? And you can do the following. So notice that we can retrieve, we're going to retrieve all the quizzes, right? And here we have quizzes. Oh, did I say quizzes? Oh no, I meant questions. Quizzes that reference quizzes. This is supposed to be questions. Sorry. Anyway, imagine that said questions. Yeah, these reference questions. And perhaps here when we retrieve all the quizzes, we don't really care about the questions, right? But if I go further, and because I want to render a specific quiz, then here I would love to have those questions, right? Right? Maybe not here, right? Because I'm just retrieving a whole bunch of quizzes, right? Make no sense to retrieve all the questions for every single quiz. It'll be a tremendous, huge query. But for a specific quiz, then yes, I would want to populate, right, all this data and have it bring over. So let me show you, right? So in the, I want this to be questions. In the query, in the service for the questions, right, where we retrieve a particular quiz, which is the quizzes service, right? This one, find quiz by ID. We are retrieving the quiz by ID, right? Which is giving us this, okay? But we can go a little further. We can say dot populate, and populate allows us to say, hey, there's a field in there, the following field, which is the field quizzes, which should be questions, okay, contains what I have declared as references, right? And indeed they are, right? The quizzes schema is declaring these questions as references to question models. See that? So by saying populate, this is going to create an additional query. It's going to say, hey, go back to the database, and fetch for me the actual objects that those IDs refer to, and then populate, replace these strings with the actual documents in the database, right? So one query to this quiz is actually going to generate 3 more queries to retrieve the questions and then fill them up here. Okay, so this dot populate goes back to the database and fetches all that data, and then we can do exec. Exec means execute, as if this looks somewhat like a program, like a script, right? Where there might be a whole bunch of references that need to be resolved, right? And you can have a whole bunch of populate, populate field 1, populate field 2, populate field 3, right? Do all these transformations, blah, blah, blah. And once you sort, right, limit, you can do all sorts of things, right? You grouping, you can do all sorts of transformations, and then you can say, well, execute all those transformations, and it gets done. So let me run it for you, restart it for you. So now if we do the query again, notice that now the questions, right, come back as the actual questions. It repopulates that data, right, instead of the IDs. Now, if you go back to the previous one here, this one is still only references, right? Because that is really the only data that is stored in the database. Notice that the database, right, notice that the questions are still just an array of strings. Okay, so that, as far as Mongo database is concerned, right, has no idea that, right, this is any way related to the questions, right? But Mongoose, right, provides us with this higher level way of interacting, right, and joining things together between different collections. Does that make sense?
Yes. Can I ask two follow-up really quick?
Yes.
The first one is, does it always assume that the reference is for an ID? Can you change the
Yes.
reference to be to another field?
Yes. No, it's an ID.
Okay.
A primary
And
key. Yep.
the other one is in terms of performance. I assume that if you have many queries, then things are going to get slow. Would you then prefer to have embedded objects?
Yes. Yep. Yep. If again, what we described earlier this week, if you can get away, right? If you can get away with instead of references, and you can put the actual objects in there, right? If, for instance, if you can guarantee that this question is only ever going to be used in this quiz, right? Then yes, absolutely. Store the actual object inside. Don't have an additional collection that then I need to join or blah, 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 right? This gives you the the fastest implementation, the embedding, not the references that we have here, but the actual embedding, right? You can, the embedding could be as follows, right? Where the quizzes schema, you can have, embedded questions, right? This could be an array of, you can bring in the questions schema. So you can bring in dot up, go down to questions and bring in the schema. You can say that this is an array of embedded questions. So now you're not storing references, you are actually storing things that look like that have this structure, right? It's as if, right, you could do it this way, or you can explicitly say, another way of doing it is that this is an object, and you can literally just copy this whole thing and paste it in there. Okay, and obviously this is easier because you're declaring it separately in a different file, and it's easier to read. But completely, you can embed it inside here. So this would be objects that would live literally inside, right? And they would not be as part of a different collection. And this is by far the fastest performance. And it's the preferred way of storing data in Mongo. But if instead you have the case where this question, actually, I want to use it not only in this quiz, I want to use it on the final exam, I want to use it in the midterm, I want to use it in a different course, okay? Because I have a question pool, right? And then I can create all sorts of quizzes with the same questions from the same question pool. Then no, we would not embed it, because this would create redundancy. Okay. Now, sometimes you want the redundancy, right? You want a copy, right? For instance, in our assignment, when somebody submits a quiz, we want a copy of the actual questions that were asked for a student and the answers that they gave. And the reason you want a copy is that the quiz can change over time, right? Somebody might fix the question, or might add a question, or might change but then you want an actual carbon copy of the original question, so that if, I don't know, at the end of the semester the student challenges his grade, you want a little audit, right, of the exact question that was asked and the exact answer you made. So sometimes you want redundancy, and most of the times you don't want redundancy. That makes sense?
Yes, thank you.
Anything else? All right, then. Thank you, everyone. That's all I had for you today.
Thank you, Professor. And also thank you for your Piazza responses today. I appreciate those.
Sure.
Have a good night.
Good night. Bye-bye.